Alrighty, welcome to DataLab4. In today's lab, we're going to look at bivariate intra-individual covariability. So how to capture how two constructs are moving alongside one another, essentially, is what we're going to do. So in the last lab, we looked at how to capture the dynamics of the time series of one construct, and here we're looking at two. So again, we let know where our data are. We load a couple of packages that will be useful, and then we are importing the daily diary data. Again, the curiosity variable that I'm working with is made up of the mean of two items, so I'm just doing that up here. You could have in previous data labs outputted the file where you had already created this variable, and so to save and make changes to your data set, you could just do write.csv, the name of the data set you want to save. So I want to now save my daily diary data set that has this new curiosity variable in it, and then call it something useful. So you could have called it, for example, DataLab4.csv. And then as you were going forward, you could just read this one in. But because it doesn't take a whole lot of time to create this one variable that I'm using, I haven't been kind of worried about using that. But I realize that that's probably something that you want to know about as you are constructing indices and moving forward through the data labs. All right, so again, just to remind ourselves what we're doing, these are plots we made in one of the first data labs where we looked at how a person's happiness in blue is changing from day to day in our daily diary data set in this one participant, and also how their curiosity is changing, so this is in red, from day to day. And we looked at this for one person. So this person, it seems like there's a kind of tightly coupled association between these two variables. For participant 107, it doesn't look like it's as tightly coupled. But the goal here is to see if we can quantify something that tells us about the strength of the coupling between these two variables across time. All right, so to do this, we're going to create an intra-individual correlation and a covariance. We're going to focus on the correlation because that's something we all kind of use all the time, and I think is a little more intuitive, but I'm going to compute this so that you have it and you can check it out if you are interested. So to do this, we're going to use a data table package. You may need to install it if you haven't already. And just as a reminder, you would just do install packages data table and run that before you run the library call to bring it up. OK, I'm going to convert the daily diary data set to a data table format that's just useful for the next steps. And then I'm going to create a data set called intra-individual indices. I'm just calling it intra-indices for short, so I don't have to type out that whole thing. Using this data set, and I'm going to create a variable that's called icore.hc, so the intra-individual correlation between happiness and curiosity. And so here I'm specifying that I want happiness and curiosity as the two variables. I want a Pearson correlation between these two variables. And the reason it's an intra-individual correlation is because we're computing a correlation for each individual separately, right? So the correlation is going to tell us about the strength of the association and the direction of the association between these two variables that are changing from day to day. And we're going to get a measure for each individual when we do this. So here is the part where it's getting the correlation, and here's the part where it's getting the covariation. And we're doing this by ID. So we're doing it for each individual. So when we run this, we end up with a new data set with 78 rows, so one for each participant in our sample. And here's our intra-individual correlation. Here's our intra-individual covariance. OK, so let's go ahead and describe this intra-individual correlation using a call that we've used previously. So the describe call, you can see that the mean correlation is 0.26. And remember, your correlation is bounded between -1 and +1. So -1 means that there's a negative association between your two variables. As one goes up, the other tends to go down. +1 would be a positive association, where as one goes up, the other also goes up. And then 0 would mean that they're not speaking to one another. They're not moving up and down with one another at all. So this is the mean. So there's generally a positive association between curiosity and happiness in the sample. So for most people, on days when curiosity is high, happiness is also high. But there's tons of individual differences. The minimum correlation in the sample is -0.9. The maximum is 0.9. And we can get a little bit more sense of the distribution of this intra-individual correlation by doing a histogram. And again, there you see your kind of distribution of this correlation. And here you can see the bounding kind of more explicitly, where it's between -1 and +1. And I guess you could note that most folks are above the 0 line, though not all. Okay, so we looked at kind of this idea of the two variables moving alongside one another as a plot that looks like this. But there's probably an easier, and this is useful because it kind of retains some of the information about changes from day to day. You know what day you're looking at as these things are moving. But typically when we look at correlations, at least I think in terms of scatter plots. So now we're going to use ggplot to make a scatter plot. So we do that by doing g on point. We're going to have points for each measure of happiness and curiosity for each day in the daily diary data of participant 105, since we've been picking on this person. And if we want to go to see what their correlation was, it was 0.55, almost 0.56. Right. And when we do that, you can see, yeah, there's like a positive line. If you were to kind of imagine drawing a line through this scatter of points, it would look like a positive line. I set the x-axis and y-axis to be to go from 1 to 100 because this is the possible space that they could have had scores. And so I just want to highlight that this person isn't using all of these scales. Maybe that's interesting, maybe that's not. But I think it kind of is important to think about how much of the space an individual is using when we're interpreting correlations like this. If we look at participant 107, and they had a smaller correlation, which you can tell, it's not like there's no clear like linear association going on here, at least when you eyeball it. And so if we look at 107, their correlation was 0.13, so it was kind of pretty small. And just for fun, let's do it for another person. This person, 109, had a pretty high correlation, so it's almost 1, it's 0.99. But you wouldn't want to write a whole story about this because they only have 3 data points. So they completed 3 days, not 21 days. And even though there's a really strong positive association where when happiness is high, curiosity also tends to be high, it's not going to win you the Nobel Prize, right? And here's the last individual. Again, fewer data points than 105 and 107, and maybe like a linear association, or at least a positive association between happiness and curiosity, but lots of gaps happening. So this intra-individual correlation is sometimes used as an outcome to tell us something about how 2 variables are moving with one another across time. One example I put here, just in case you're curious, you can go and read that. They capture the intra-individual correlation between positive affect and negative affect. So those are their 2 variables. And this intra-individual correlation captures the extent to which people experience bipolarity in positive and negative affect. So that's the kind of emotion dynamic construct that they're going after. And so just to kind of tease this apart a little bit further, in depression, so they're looking at this bipolarity of positive and negative affect in the context of depression. If negative affect is high, then positive affect is low. So there's this kind of bipolarity, like I can tell something about your positive affect based on your negative affect. It's that they're going to be opposite. But outside of depression, you see a more complex emotional experience where negative affect and positive affect aren't associated or aren't as strongly coupled across time as they are in depression. So that's kind of cool. It's like a neat way to capture this idea of how two variables are moving across time and to start to get at emotion differentiation type questions. So this is in the context of emotions. I'm curious if you have ideas about how this might work out in the areas of research that you work in. Okay, but with that said, we would want to be cautious in using the intra-individual correlation as an outcome variable here for reasons you can probably start to see by looking at these plots. You know, can we really trust a correlation based on 3, 10, 21 observations? The more data you have, the kind of more confident you can be that you're capturing something real about the way an individual's two variables are moving across with one another across time. But maybe the experience sampling data that we haven't looked at yet, that has more data points per person, could kind of help us overcome this limitation of too little data. And this paper uses experience sampling data rather than daily diary data. Okay, before we go into that, the alternative measure you could use, and it's one that you're again used to applying in the between-person context, but now we're going to the within-person context, is an intra-individual regression. So again, another way of indicating how one variable moves along with another. So we're going to use this function from the Plier library. So again, you might have to install that. I'm creating a data set called intra-individual models, where I'm taking my daily diary data, and for each ID, I am regressing. So LM is the OR's way of saying I want to do a regression on this data set that I pulled out here. And again, you can check out the LM function and also thinking about missing data, about what OR is going to do with missing data that's in your daily diary time series. But here I'm going to regress my curiosity variable on my happiness variable. And okay, so I did that. And then now I'm putting it into a data frame called intra-individual coefficients, or ICOFs. And I'm taking the coefficients, so you're going to get like the intercept and the slope from your regression. So if we were to open up that data set, you would see you have your ID variable, your intercept. And so remember from regression, your intercept is just the mean of your outcome variable when everything else is 0. So this would be your like mean curiosity. Yeah, this is your slope of happiness. So the coefficient that tells you as happiness increases, what's happening to your outcome variable, which in this case is curiosity. And so we'll just give them kind of easier names that are a little easier to work with. And that's what's happening here. So if you open this again, we now have ID, curiosity, intercept, and happy slope. It's a nice kind of variable name, I think. Brings some joy. Okay, so now we're going to describe the happy slope. So for our 78 people, the mean slope is 0.26, so it's a positive slope. As happiness increases, curiosity increases. So let me rephrase that in how we would actually phrase that. On days when curiosity is higher than usual, on days when happiness is higher than usual, curiosity also tends to be higher than usual. But again, lots of individual differences. So here's the minimum value of the slope and the maximum value of the slope. We're not in correlation land anymore, so you're not bounded between -1 and +1. But this is still telling, the sign is still telling you about the direction of the association. Okay. Let's see how the intra-individual regression slopes correspond to the intra-individual correlations. So now we're going to create a new data set called for plots, because we're going to use this data set for plotting. You might be able to come up with a better name. And we're going to merge this ICOF's intra-individual coefficients data set with our intra-individual indices data set from our daily diary data. So when we merge that, you want to specify what variable you are going to use to merge the data. So you have to let OR know like which rows go with which, and we want to do that by ID. And so now you have one row per ID, but now you have both the intra-individual regression coefficients as well as the intra-individual correlation coefficients for each individual. So then we're going to do a scatter plot on our 4 plots data, where we look at the happy slope and how it's associated with the intra-individual correlation, and they should be pretty similar. Yeah, I've just added that fit line for kicks. They're not exactly the same, but that's not surprising. And that can be some fun homework looking at the difference between regression and correlation. All right. But like I said, you wouldn't necessarily want to take these data, these bivariate intra-individual indices as outcome variables, because there's quite a lot of uncertainty about how well they describe any individual in the sample, right? Especially for individuals where there's like, you're computing a correlation on 3 data points. So let's look at our experience sampling data that we haven't looked at yet. So to confuse us all more, for some reason, I wrote this down as EMA data. So I'm using experience sampling and EMA interchangeably. We're going to read this in, and we're going to look at it for a second. All right. So a couple of things to notice. There are 2 ID variables. One is life data underscore ID. Life data is the app that we used to collect these data. So these data were not, unlike the daily diary data, were not being collected via Qualtrics. Instead, life data is an app that you install on the participant's phone, and then it just runs a protocol for you in a way that's pretty nice. But the nice thing about life data, in order to make it difficult to take someone's data and link it back to who they are in the real world, which would be an issue for privacy, it gives each person a randomly generated ID number that's called life data ID. But that makes it difficult then to merge back with your daily diary data or your baseline data. So usually in like the startup session, the very first session that people do, I have them write down their actual ID. So if there is an ID variable that corresponds to the ID that the person has from their daily diary and their baseline data set, which will be the main ID variable that we're going to use going forward. I just want to explain why you're seeing 2 IDs. Okay, so you have the time at which each prompt was completed. You'll notice there are 6 sessions per day. So on the 2nd of July, there was a morning notification, and then there were 1, 2, 3, 4, 5 more notifications throughout the day. And then for day 2, you start again with the morning and 5 more notification, and this repeats for 21 days. So we get up to 6 reports each day for each individual for 21 days. You'll notice that there's a blank row here. And the reason for that has to do with assumptions we make about the equal spacing between prompts when we get to some more advanced modeling. So in some of the advanced models, one of the assumptions is that the space between prompts is almost equal, right? And I am more comfortable kind of assuming that there's approximately equal spacing between my momentary prompts throughout the day than I am in saying that the prompt that happens at 5 p.m. on Monday and the prompt that happens at 8 a.m. the next morning, that's an equally equal spacing. It's not, and it's very different from the rest of the spacing that's happening throughout the day. So I like to put this blank row in between my last prompt of the day and my first prompt of the next morning. And this we'll kind of see this as missing data, and it's not going to try and predict your morning score with your evening score. So it's not going to try and make that like 12-hour leap in prediction. But we'll get to that a little later. I just wanted to kind of give you a heads up on why that's happening. In order for this to work, it needs to have an ID variable here. It doesn't have it for the life data ID, but it does have it for the other ID. So you don't have to worry about that. And don't use this going forward is basically what I'm saying. Don't use the life data ID, use the other ID. All right, so if we look through, you can see some familiar variables from our daily diary data set, but now instead of asking people to retrospect on the day as a whole, so at the end of the day saying, how happy were you today? The questions are, as you'll see in the codebook, are phrased more like, right now I feel happy, right now I feel sad. And again, just like the daily diary, they go from 1 to 100. So yeah, it's tons of stuff. You also have some binary variables that tell you about the context that people are in. Are they with classmates? Are they with family? Are they with friends? Right, let's go to the end of our data set to see if there's anything else that we care about. You have some hours of sleep, and here's the ID variable that I was talking about. So that's useful. So the morning survey and the momentary surveys are pretty much the same, but you'll notice that only the morning survey has information about sleep because there was no point asking them about sleep throughout the entire day. Okay, so that's just a quick overview of our experience sampling data. I wanted to talk about the blank rows between each day, which I did. And I'm not going to do a whole lot of descriptives with these data, but you should feel free to play around with the code from DataLab4 to run some descriptive statistics to see if anything looks weird with the data. And you now have the skills to do that. Essentially, now that you've done it with the daily diary data set, there's not that much different with any other type of intensive repeated measures data that you're going to come across. Okay, so for now, I'm going to check out the happiness and curiosity variables in this experience sampling data. So let's just describe that for the sample as a whole. And I plugged it up here. The mean was 67. Min and max was 1 to 100. There's no crazy values that shouldn't be in there, so that makes me happy. Again, curiosity was measured with 2 items. So I'm just taking row means, and then I'm going to describe this. Fantastic. You will notice that there's more data for happiness than there is for curiosity. So if we were going to go forward and write about this variable, that's something we would want to investigate. All right. And now we're going to create plots, just like we did for the daily diary data set for participant 105, looking at their curiosity from moment to moment. And now we're not talking about day to day. We're talking more about from every 2 to 3 hours. You can get at the actual timing by looking at the data set and looking at the notification times. So you're talking about anywhere between 1 to 2 to 3 hours. Remember that this was signal contingent, not interval contingent for everything but the morning survey, so that people didn't anticipate having to respond. Okay, so we're going to look at curiosity across time and happiness across time. And we're also going to add points. I think when you get to this type of data, having the points makes it easier just because there's a lot more data than you see in the daily diary data set. So this is pretty neat. It looks similar to the daily diary data set, but now it's a lot denser. So we have, our, curiosity is in red and happiness is in blue, and they're going up and down. There's lots of data. This is really exciting. There is one thing that I sometimes like to add to these plots, which is some indication that the data are coming from different days. Like right now, there's no indication that there are unequal distances between these different data points. I'm not so much worried about that within a day because the differences are on the order of minutes. But as I go from one day to the next, there's a big, at least 12-hour kind of jump. And that's just useful to keep in mind so that we don't forget that when we go to modeling our data. And so one way we can do that is we can use our geomrect function that we used in DataLab4 to put a background variable. And I'm just going to use the day variable, which tells us which day of the study it is, into the background. So let's see what that looks like. It's very pretty. This is probably not the best way of doing it. You would probably want a sharper demarcation from one day to the next, but I think it looks nice. And I am now aware that these data are being collected on different days. Another thing that you could experiment with is whether instead of having a count variable here, you could have a time variable like minutes elapsed since the beginning of the study, for example. That could be kind of neat. Okay, so now that we have these data, we are going to do the same thing we did for the daily diary data set and create an intra-individual correlation. So this is essentially the same code from above, but now instead of applying it to the daily diary data, we're applying it to the EMA data. And you would just have to change the names of your XY variable and what you want to call the outcome variable. You could call it the same name, but it makes sense to change the name because when we merge later, you don't want two different variables in two different data sets to have the same name. It just makes merging a little bit more arduous. Okay, so I've created an intra-individual correlation of how happiness and curiosity are changing within person. And I'm going to describe this. You'll notice that the EMA data has an extra person that the daily diary data doesn't have. So surprise, when you're working with real data, things like this can pop up and you will want to go investigate them. We know about this and we've sorted it out, but just something to be aware of when you're working with your own data. Okay, so the mean intra-individual correlation is 0.34. The minimum is minus 0.2. The maximum is 0.76. And again, this is a correlation. So, you're bounded by -1 and +1. All right, so we can do a histogram to kind of get a better sense of how this variable, this intra-individual correlation between happiness, that's not how you spell happiness, is distributed across the participants in the sample. And let's, for kicks, plot the correlation between happiness and curiosity for participant 105. So if we go to here, we can see that they had a correlation of 0.6. So we should expect some sort of positive association. And that's actually pretty nice. And now that we have more data, basically, than we did for the daily diary, I'm a lot more comfortable with using this as an outcome variable, potentially, if that's something that I was really motivated to do. And if we look at 107 and this person, let me see, EMA intra-indices, 107, they have a correlation of 0.47. Wait, really? That does not look like a positive association to me. EMA intra 107. Huh, okay. So that's, I guess it is a positive association, like decently sized. And there's more data there. So you can have a little bit more confidence in that than with the 21 days of the daily diary. But even though 109 had the possibility of having like up to I think over like 100 data points in the momentary data, they didn't fill it out that many times. And so I would not be super confident that this is telling me anything about this individual with a lot of accuracy, right? And for 127 again, now we have more data. We can be a little bit more confident with what's going on. Okay, we're going to now merge the indices we created using the daily diary data with the indices we created using the experience sampling data, just to see how they compare. You would probably expect some correlation between the daily diary and the experience sampling data, given that the daily diary is reporting on the same day and the same person, right? It's just saying, but they are different. So the EMA data is telling you the correlation between measures where you're saying, right now I feel happy, right now I feel curious, whereas and you're collecting that multiple times throughout the day. The daily diary data is saying, today as a whole, I was curious, today as a whole, I was happy. And so the time scale there is a little different, and the fact that they're retrospecting rather than talking about how they feel right now. So we might expect some differences conceptually, even if not like methodologically. All right. So the way we merge, we are creating a new data set called EMA daily diary cores. So we're going to look at the intra-individual correlations. We're going to merge our two data sets by the ID variable. And when we do this, we have 78 rows. The person who had experience sampling data, but not daily diary data was dropped when we merged. If we would like to include that person, you could just do all is equal to true. And now you have 79 observations. And the data that they're missing, so they're missing daily diary data, just comes up as NA. So that's something important to, it's a small thing, but it's important to think through when you're merging later on, just so that you have kind of consistent numbers across your data set. All right, so we're going to take this new data set that we've created, and we're going to just create a scatter plot, so G on point, looking at the intra-individual correlation between happiness and curiosity from the EMA data, experience sampling data, with the intra-individual correlation from the 21-day daily diary data. And as you would expect, you see a positive association. It's not perfect, but you know, there's clearly some similarities between the indices we get from each one. Okay, so that's the main stuff I wanted to go through today. And so for homework, you just want to go through and switch out the happiness and curiosity variables for the ones that you are working through. Feel free to change from week to week. I don't expect you to kind of find your desired one and stick with it. If you can, great. If not, don't worry about it. So I would like you to do that. That would be great. I'd also like you to start thinking about whether looking at the bivariate association between two constructs that you care about in your research would make sense. So in the example of bipolarity of positive and negative affect in depression, for example, does anything like that apply to your work? The other thing I want you to look at on your own is information about the Fisher-Z transform. Correlations are bounded between -1 and +1, which is not the ideal thing to have as an outcome. And so often people take the Fisher's order Z transform. You can read more about it there. And then you can see what happens to the distribution of the intra-individual correlations when you take the Fisher-Z transform. Cool. All right, well, have a good rest of your week.